Hello and welcome to another Developer Essentials. So this time what we're going to be taking a look at is some things called enumerations and switches. And I'm grouping them together because they do have a little bit of overlap, and they're things that we don't necessarily use all the time in terms of creating our own ones, but they can be really useful and can help out with some very specific cases. So what we're going to do is we're going to dive in fairly quickly just to see what these things actually are and how they work. So I'm just going to rename switches demo. Just got that in that scene, and as always, put my code in a separate folder. So what I'm going to start with is a script that is just going to be about demonstrating these things called enums. So enums demo. So enum is short for enumeration, and we have in some of the other videos we've seen briefly sort of using them for things like controlling different modes that stuff can be in. But with this, I want to really dive into in detail what an enumeration or enum is, how we can work with them, and some of the really cool, handy things that happen with them. So an enumeration is a couple of things, and it's important to understand how these things are stored and worked with. So let's take a scenario that we've seen before in terms of being able to set up an enumeration for controlling the different way that something might happen. So we could set up here, let's create an enum, and what this is going to do is this is going to be one that controls how this particular object can move. So that's what this is about. So movement type. And I'm going to, it's not strictly necessary, but it's part of the convention of how I name these. So when we create an enum like this, what I'm doing at the moment is I'm not creating a variable. So I'm not creating something that I can store anything into at the moment, but I am creating a new type. I'm defining what the enumeration looks like. So movement type is the name of the enumeration, and then I give it particular values. So I could say that, okay, well, one of the movement types might be that it is using, let's say one of the movement types is slow bounce. I might also have one that might be fast bounce. I could have one that is slow pulse and one that is fast pulse. So with enumerations, we give an overall name for the enumeration, and then what we enter is text. So we enter names for particular things. So that's one of the handy things about enumerations. We're giving things particular names, because what that allows us to do is, okay, I create a new variable that I want to be able to store one of these enumeration values. So like movement type is the name of that variable type I've created. And I could say movement. And then when I set it to a value, I have to set it to one of these ones. It's giving me that as a nice option that I can code in. It means if I get a typo, I'll actually get an error. So it will pick that up as being incorrect. So it auto-completes the names. It tells us if we've gotten things wrong. We'll get errors appearing up in Unity for that. It won't let us run our code if we have typos there. So, because the alternative is I could have a string and I put in the text, slow bounce, fast bounce, but then I'm not going to get that error checking if I had that wrong. You know, if I had something like this, bad usage of strings equals slow pulse. You know, I've got a typo compared to what I'd likely be checking against that, or I could have a typo in the section where I'm writing that check. It makes it really easy to have errors happen. So using strings, things like that for it is not ideal. Similar if we just used hard-coded numbers, because I could say, okay, well, let's say slow bounce is 0, fast bounce is 1, slow pulse is 2. I could have an integer, and then I'm selecting just from an integer. But again, I could put in the wrong value. With an enumeration, it makes it very difficult to do that. There's error checking that's just baked in that will happen with that. But there's actually a really nice advantage with enumerations, and that is that as well as having this name, they actually have a value associated with them, an integer value. So I can actually do something like this. Well, debug log slow bounce is, and then I can say e movement type slow bounce, and we can actually see it's even already putting it in the tooltips here. You can see slow pulse is 2, so it actually has a numerical value associated with it. And the way enumerations work is if we don't give any specific indication, if we don't tell it, then it will actually number them automatically, where this one will be 0, this one will be 1, this one will be 2, and then this one will be 3. So we'll automatically number them so that each one is unique and that it just increments the entire way. Really handy. Would mean that I could, and this is less needed in C#, but one of the things you can then do is you have num movement types, because then this, you leave this down. This is something that I would very commonly do in C++. So new types always get added in here. And this will always then correspond to the number of movement types that we have. So if you had a for loop, you could do a for loop that counts up to num movement types. Really handy for actually working with the enumerations like this. So let's see what we get from this output, and we're going to take a look at how we can do some of these conversions to and from integers, to and from enums and integers, and how we can do a couple of other bits and pieces with this. So I'm just going to start with creating a cube, and I'm going to attach my enums demo script onto it. And then what we'll do is we'll just run this and we'll see what we get output-wise, just as a starting point. So, okay, well, it's saying slow bounce is slow bounce. This is one of the nice things that in the debug logs, if you use the actual enum value, it comes out as the particular one here. But what I can do is I can do this. So I can also, I'm going to change this around a little bit, because I could then say like that. And let's see now what we get in terms of output. What we're expecting is to see that it's showing a numerical value for it. So you can see slow bounce is 0. So that's pretty handy. We can debug, log out, and the enumerations. So we can convert it to an integer like that. We can also convert it the other way. So this is convert from enum to int. This case, we're converting from int to enum. So what I would be able to do is say, okay, debug log 3 is, and then what I would say is e movement type 3. So let's see what that looks like if we're doing this conversion, which is something that is known as a casting. So casting is a process of converting between types. As you can see, can convert from an integer to an enum. Super handy. So it means that we can do, potentially calculations on things like this at times as well. So it means we can easily convert from an enum to an enumeration, to enum to an integer and an integer to an enum. Super handy. What if we wanted to list out all of the values? Well, I have my num movement types here. So dump all enum values. And this is where I said having that num movement types one can actually be a really handy thing. So I could be saying, okay, well, enum index is equal to 0, enum index is less than movement type, num movement types. Now I do need to cast this to an integer, so it will not auto cast to an integer. That's something to be aware of. So enum index, whoops, is, and then I would do e movement type enum index. Autocomplete is going to be the death of me. But this will debug log out all of the values there for the enumeration, so we can see that conversion. So this is one way if we needed to iterate over everything in an enum, which is a thing that we do at times need to do. And we can do that, and we can see it's going through and listing out all of the particular ones, which is cool. And because we did less than the num types, we don't output anything beyond that. So that's a really effective method. The other method that we can use is we can actually say, and this is system enum get values. So if we did this and we give it our e to do type of e movement type, so this gives us out the enum values. So let's see what we get from this. So what I'm going to do, value in enum values, debug log value. So let's see what this gives us out. So I'm using var here as an easy way of, okay, well, I don't want to have to manually control the type. I could, but this way I don't need to. So let's see what this shows us as the output. What is, if we use the get values, what do we actually get from this? So we can see if we use get values, we get the actual enum names appear. So it's giving us the type of this. So it's giving us out the individual values for the enums. Now, there are times where we might want to have those as actual text. So enum values as strings. So we have system enum get names. So we can do get names, and again, give it the movement type. This can be useful for things like in a custom inspector if you're wanting to display the names of the particular enums there. That can be really handy. It gives you them as a string. Var value enum values as strings. And this will look exactly the same, but it will be giving us them as an actual string, whereas the previous one is giving us them as the actual e movement type. So if we run this, we do get the exact same output, but what I can do is as value get type name, just so we can see what type it is outputting it as, because we will see that there is actually a difference here, and because these serve different purposes. One is more user-facing, the other is more developer-facing. So it runs, and we see we get, so this retrieves, gets all enum values as their enum type, e.g. e movement type. So the array is that this is getting back holds movement type. So this version is good for iteration. Good for iterating over all values of an enum. That's what that one is perfect for. This one gets all enum values as strings. So it'll give the actual name of these as a string. So it gets all enum names. This is good for displaying to users. So e.g. custom inspectors. So if we're customizing the inspector in Unity and we were wanting to display stuff, then we could be using this approach to get all the particular strings that we might want to be showing there. So really handy, really great way of actually being able to work with the stuff. And if we take a look at other ones, then we also have this pass option. Because with that, well, if we've got things as a string, we might be then wanting to try and be able to go from a string to the actual enum value, which we can do that, and we can demonstrate that here. So what we can do is our enum value equals system.enum.parse. We could also use try-parse. So try-parse is great if you're wanting to have it potentially be able to fail and indicate that. So if you're processing really complex data or data that you want to do some extra validation on, I would be using try-parse. For something like this where I know it's going to be valid, I would just use parse. So I can say parse, and I can tell it, okay, it's an e-movement type that you're reading from, and value is the particular one. So this, we'll just have it display at the enum value, so we can just check, because we want to make sure that this is actually working as expected, and that we are correctly, from those strings, able to convert back. And we can see slow pulse as string is slow pulse, so it's managing to convert all the different ones. So we've got our enums. We can see how we can set them up here. We can see how we can convert from an enum to an integer. We can convert from an integer to an enum. We can loop over all of the values if we're using this approach of having a num entry there. We can also retrieve all the values. So we can get all of those particular enumeration values easily enough, or we can retrieve the names. And if we need to, we can convert from the names to a string. So convert from enum name to enum value. So we can do those conversions. So that's pretty cool. There's one other trick of things that we can do with enums that is really, really handy and gets used a lot. And part of the reason this trick gets used a lot is it allows us to actually store information really efficiently. So we've seen this type of enum where it's auto-numbered. We can actually manually control the values that get set. And so we could do that, and we could have something like e-movement capabilities. So we're describing the types of ways that a character can move. So we could have ground-based movement. So we could have on ground. We could have in air, in water, and below ground. So that's pretty cool. But what if we have a character that can walk, swim, and fly? Or that can be on the ground or below the ground? So they can be in multiple states at the one time. So what we can actually do is this is where we can do something a little bit clever, because we could set that up as multiple variables, but that's extra data. That means we're using more space for that, but it also means more stuff to pass around. It's kind of, not ideal. So we can override the values that get assigned here. So I could do, something like this, where, okay, well, I'm going to set these to very different values like this. So I could say, like this. So what that would allow me to do is I could check, okay, well, is the one is the value below 10? I could check the different values there, but decimal values are not the nicest to work with for that. What we really want to do is we actually want to go to the low level of how data and numbers in particular get stored. So if we have a value like 7, it's not stored as the number 7, it's stored in binary. So binary just has the digits 0 and 1, but we are able to express more larger numbers by having a larger number of bits. So in binary, if we were counting in binary, well, 0 is 0, 1 is 1, 2 is actually 1, 0. 3 would be 1, 1. 4 would be 1, 0, 0. 5 then ends up being 1, 0, 1. 6 ends up being 1, 1, 0. And then 7 ends up being 1, 1, 1. So we could count in binary. And binary, we've got an individual bit. So we could be, if we had the ability to control and set individual bits, then we could use in 4 bits, we could store all of this, which is pretty handy. And we can do that. The easiest way to do this is if we write this, like this is how this would look. Oops. So this is the left shift operator. So 1 shifted left by 0 is going to give us, this is going to be a value of 1. This is going to be 2. This is going to be 4. And this is going to be 8, which we can check and see. So it's showing what those are going to be. Unfortunately, it doesn't do the actual calculation there for us. It'd be really handy if it did. But what we'll notice is if I bring 8 in here and line these up, we'll see that these correspond to individual bits. So 1, 2, 4, and 8 are each controlling individual bits. So what we could do then is, okay, well, if we've got 1, 1, 1, that's going to mean we can move on ground, in air, and in water. If we have 1, 1, they can move on ground or in air. If they had 1, 1, 4 ones, then they can move ground, air, water, below ground. So it gives us a way of being able to indicate more information, but store it in a really compressed way by using this shift operator, because this says how many bits to shift something by. Because what we can then set up here is now we don't have a movement capabilities, we actually have an integer. So movement capabilities. And what we would do is we would say something like, okay, well, we're going to default this to be able to move on ground. So we want to say on ground, and we want to combine that with movement capabilities in air. And we need to cast these to an integer. like this. But what I'm using here is, so this is a single pipe. So we've seen the double pipe with conditionals, with if statements, where that is combining things from a Boolean logic point of view of this thing or this other thing. The single one here is what's called a bitwise OR. What that is doing is that performs that OR operation, but it does it bit by bit by bit on the individual data. So it's as if what is happening here is there is a for loop that is looping over each particular bit and is ORing each individual bit with that corresponding one in here to get the answer. So that's effectively what's happening there. So, okay, let's take a look at what our movement capabilities are. So we could say debug log movement caps is, and then let's log this out so we can see what the value is. And then what we'll see is how can we actually check the movement capabilities for something. Because it's one thing to be able to store it in there, but we really need to know how we can actually check the values. So we can see movement caps is 3, which is what we expect, because we set it to on ground and in air, which 1 plus 2, 3. So log out the movement caps, and then we would be able to do, okay, check if can move in water. Actually, no, I'll say can fly for now. So what we would do is we would say, well, F, movement capabilities, and again, we're using a single ampersand, E, movement capabilities, and in air, and if that is equal to movement capabilities, E movement capabilities, in air. Debug log, can fly. Now we need to, as always, cast these to an integer so it can do its comparisons. And just for the sake of clarity, I would normally group things with parentheses like that. So ampersand, when it's a single one, much like how the single pipe is a bitwise OR, this does a bitwise AND. So the result of, if we take, so say we had 111 ANDed with, well, in air, we know should be, so this is that. 4 is going to be 0, 1, 0, 0, and 8 is going to be this. So we are ANDing with in air 0, 0, 1, 0, which that will give us 0, 0, 1, 0. So the bits that are the same in both, and in particular the bits that are 1 in both, will come through as 1. If they are anything other than 1, they come through as 0. So that is what a bitwise AND does. Whereas up here, the bitwise OR, what we're saying is 0, 0, 0, 1, ORed with 0, 0, 1, 0 is going to give us 0, 0, 1, 1. So this, anything that is 1 in either of them comes through as a 1, whereas in this one, only things that are a 1 in both come through as 1. So we AND it with the value we're wanting to check, and then we check if it's equal to that value. So then we can test this, and what we should see is we should see the message that it can fly. So it runs, and yeah, we get the message saying that it can fly. So just to recap these bits that we've seen with the enumerations. Enumerations are great when you are needing to have different ways, different modes, things like that something can work in. If you're wanting different categories for things. So anytime you're thinking of sort of categories, classifications, modes, some forms of grouping like that, An enumeration is definitely the kind of thing to be thinking about. That's likely what you're looking for there. Enumerations have a name associated with them, as well as a name for the actual sort of type, the enumeration itself. The actual enumeration entries, the values there, are an integer, so it's stored as a number. And if we don't provide a number, it automatically numbers them, starting at 0 and going up. We can convert an enum value to an integer using a cast, and we can also convert an integer to an enum using a cast. So we can convert in either direction. We can have an enumeration that's the number of entries and use that for looping over what the values, if we wanted to do something with every category or classification in the enumeration. We can also retrieve all the values if we want. So we can retrieve the specific values, or we can retrieve those names, which if we need to, we can convert those names back to a value. So the retrieving the values is mostly geared towards iteration. Retrieving the names is mostly for display purposes to the user. We also saw that we can override the values that are set. And in particular, we can, if we need to store multiple related things, then we can use this approach of assigning values that correspond, each value corresponds to a unique binary digit and unique place in a binary number, so that we can then set particular entries here really, really easily, and then we can combine them using a bitwise OR, and we can test them using a bitwise AND, as just as an easy way of being able to check these capabilities. And so that's the key stuff there with enumerations. Okay, so let's take a look now at switches and the kind of things we can do with that. So I'm going to set up another script. This is going to be switches demo. Now, switches are a thing I really don't use that often. I really don't use them particularly often. And it might be an artifact of the kind of things that I'm doing, but I tend to find I don't often have a use case for them. So the idea behind a switch, and this is where I'm going to, the enumerations, things like of that do come in handy with this. Because say I had a category for something. That was a classic thing that we said is a really good fit for enumerations. So E category, and this might be a category of thing within the game. So we might have stuff in terms of level geometry. We might have static objects for just static decorations. We might have characters, interactable items, pickups, and we can have different particular things there. So we might want to have different things happen based upon the particular category. So, and then category, it might default to that. So, okay, we might want to have different things happen here based upon that category. Now, what I could do is I could say, okay, well, if category is equal to E category level, else if category is equal to E category, and this gets really annoying very rapidly. Especially if the number of categories grows to be really large, it's going to be messy. Also, error prone. That's the other thing there that we need to be aware of, that the potential for typos, for missing things, and as we saw, because of the auto complete was prompting based upon alphabetical order, so I could easily miss particular ones there. So it's not a great approach. It ends up being a lot of repetitive code, and it ends up also being code that I don't have an easy way just by default for picking up problems. I could do an else at the end, but it's a bit more overhead working with that with a large number of items like this. And this is where a switch comes in, and this is where switches give us a better way of doing something like of this. Okay, so let's have a look at how we set up a switch. So the syntax for these looks kind of like this. So we would say switch category. So what we do is we say switch and then we give it the variable that we are switching on. And then inside that we have case. So this is our way of saying, well, f category is equal to a particular value. So we would say case, e category level geometry, full colon, and then break. So break signals the end of that case. What this allows us to easily do is, so okay, well this will do something for level geometry. Maybe I want to have something where interactable items and pickups both do the exact same thing. Well, I can do that because a case, if it doesn't encounter a break, it falls through to the next one. So break prevents it from falling through. So this closes off the case, switch exits at this point. This one has no break, so it falls through to the next case. And I could have as many different ones as I wanted here. I also have default. So this runs if none of the other cases matched. So this allows me a way of then detecting, so I could say, debug log error, no handling for F category is, and then I could log out the value. So it gives me an easy way for making sure I've got that error checking. So we'll reliably go into that, and then you can have a debug log here, interactable or pickup. We could then have a debug log here, level geometry. So it's a much easier way of doing all of those checks where the syntax is a little bit cleaner and easier to read. It's also a little bit clearer that we've covered everything, and the advantage of default there, which you can enforce it actually throwing up errors if you haven't put in the default case and it is not handling all of the scenarios. That's something that can actually be looked up. So code analysis tools can pick up on things like that, where you've got a switch and you're not handling all of the potential values, and that can convey then an error message for you to improve code quality, which is really handy. Because if I now run this, and we'll see, so we can see I've got the category set to level geometry. We'll let that run. We get level geometry. Let's change to static decorations, which I didn't implement any path for. So we get our error message, which is good. If I switch that to interactable items, we should see we get a message appear. So we do. And then we should, if we change this to pickups, get the exact same message. And we do. So gives us a really easy way of checking all of the different scenarios there, and allows us to just nicely handle the default scenario of if nothing is actually done. We can group our ones, so we can handle that if there's multiple things, just route to the same block of code. We can easily do that. Now, one of the things that we can't do, because you might be wanting to, okay, well, there's some common code I just want to run for pickups, but I then also want to run some stuff just for interactable items. And you might be thinking, okay, cool, I'm going to chuck in, interactable and wanting to have some extra code there, and we actually can't. That's not something that's supported. We can see if we come back here, it's going to be getting grumpy at us, so we can't actually do that. We have to, in a case like of that, we would need to have a separate entry there for just the interactables with a break after it for doing that kind of logic. But so switches I don't use a heap, but if I'm needing to do stuff where I'm doing a lot of, and this is the key that I look for, if I am finding that I have had to write, well, if this thing is this value, if this thing is another value, if this thing is another value again, if I'm having to check multiple different ones and do different things, and generally my threshold is around sort of 3 to 4. If I'm finding I'm writing more than that, then I'll look at using a switch. But basically, if you're writing lots of, well, if this particular thing is equal to this, and then checking against another value and another value, then using something like a switch is ideal. We can use switches with other variable types. We've used it in this case with an enum, but we can use it with things like integers as well. Not with floating point numbers, obviously, but we can use it for things like integers and so forth there as well. And super handy, gives us a much more efficient way of setting this stuff up. And the big thing I'd recommend there with switches is making sure you do have that default case in there, just so that if you have missed an entry, that you're getting the error checking there for it, so that you can make sure that you haven't missed anything from your code and you've got all of the components in there. So just to recap on the key bits that we've looked at. So enumerations are a way of defining our own variable types. And in particular, once we were creating things like a category or a classification, some way of sort of often grouping things is where we typically use them, or we're indicating a type of something. So enumerations are really handy for that. They allow us to provide a name for a thing, but then behind the scenes, those are actually given an integer value, and it will automatically do that. It's really handy as a way of grouping and storing stuff. It's far better than using sort of strings for storing that same information, because we get error checking and it will be able to give us notices if we've gotten things wrong there. And it also auto-completes alongside that. We can override those values and put in manual ones if we're wanting to do things where we're compressing more of those elements and using an enumeration for then storing multiple things in the one integer. We've seen how we can do conversions there to and from integers and strings with the enumerations. And then we took a look at switches, which are really handy for when we are testing a variable against multiple different values. And generally, when we're looking at sort of more than 3 to 4 things, that's where using something like a switch can come in really handy to be able to make that a lot easier for working with. And the key thing when we're setting that up is we want to make sure we do have a default entry, so that if we've missed handling a particular case, that we actually get error messages for it, and that we can then be responding to that accordingly. Thanks, folks. If you're looking for the code for the project, then in the description below, you'll find a link to the GitHub. And on the GitHub, I've got the code for this project and for all of the other projects there freely available. And if you have found the video helpful and you'd like to support the channel, then throwing in a like or subscribing is always a huge help. If you're looking for further ways to support, then I do have a Patreon set up, and that's going to help me keep managing to do these videos for a long time to come, which is going to help more people make cool things. And that's awesome, because that's what this is all about, is helping more people make more cool things. And that is all. Thank you.